Hello everyone. In this video we'll take a look at the naive Bayes classifier. So basically in the previous video what we saw is probability of E given A is probability of A given E into probability of E divided by probability of A, and this probability of A can be expanded as probability of A given E into probability of E divided by, you can write this as probability of A given E multiplied by probability of E plus probability of A given E complement multiplied by probability of E complement, right? Let's just stick to this form of the Bayes theorem for now. Okay, now instead of E and A, let's consider Y and X. And what do you mean by Y and X? So basically what we are trying to predict, or what we are trying to do here is, what is the probability that the class label, this here what we are trying to predict is the label. Okay, so what is the probability of a given label, or what is the probability that the label will be Y given that these are the attributes or features or dimensions. Okay, so this, if we write in terms of the Bayes theorem, this will be probability of X given Y multiplied by probability of Y divided by probability of X. Okay, and here what we did is we expanded P of A using the total probability theorem into this, but let's keep it like this, okay, for now. Okay, now let's try to understand this in detail. Okay, now the variable Y, which is the label, or we also call it as the class variable. Okay, we also call it as the class variable, okay, or label. This represents whether it belongs to a positive class or negative class. Okay, and X represents the parameters or features. Now X in fact over here is like a vector which consists of, let's say, n number of features. Okay, so the same thing we can write it as probability of Y given, we can expand this vector, the feature vector, completely, and we can write it like this. Okay, so probability of Y given x1 comma x2 comma xn is equal to, now here comes the naivety or simplicity, or basically in plain English, if you say that someone is naive, what do you mean by that? You say that someone is, a simpleton or slightly idiotic. Okay, so the simple naive, or very idiotic assumption, basically the naive assumption of the Bayes theorem is that all of these features x1, x2 up to xn are completely independent of each other. So therefore we can write this as probability of x1 given y. We can write probability of x given y as a product, probability of x1 given y into probability of x2 given y, and so on up to probability of xn given y. So we have expressed this probability of x given y as a product like this, and probability of y, this part remains as it is, and denominator again will express as the product of all the features. So probability of x is probability of x1 multiplied by probability of x2 multiplied by probability of xn. This is with the assumption that all the features x1, x2 up to xn are completely independent, and there is second factor, that is they are identically distributed. They have identical effect on the outcome or on the class label. Okay, so these are the two naive assumptions. These are the two naive assumptions of the naive Bayes classifier. What are the two naive assumptions? First naive assumption is that x1, x2 up to xn, all the features are completely independent. They are completely independent of each other. Okay, they are independent of each other. One feature does not influence another. And the second naive assumption is that each of them equally influences the output or outcome. Each of them influences the outcome or the class label or the class variable y in equal amount, or each one of them has an equal influence on y. So these are the naive assumptions. But we'll proceed with naive assumptions just because it makes our calculation simple and we are not quite off from the actual result. Even if you take into account the dependence among the variables or dependence among the features and one feature affecting the outcome more, our calculation will become complicated, but the end result is not much different. So as long as that is true, we can use this